Thanks, everybody. Welcome to my talk. My talk today is a very lightweight talk on developer-friendly approaches to Kubernetes. My name is Colin Griffin. I run a software consultancy called Krumware. We're located down in Columbia, South Carolina, and we help companies become better technology companies or just technology companies in general. My experience and my journey over the years has been very much an application developer journey. I was dumped into systems engineering and core .NET development and a lot of those kinds of things, working on Silverlight and other front-end technologies that Google chose to make die. It forced me to go down a path of needing to learn JavaScript, web components, virtualization, Docker, probably the same path that a lot of us have been going down recently. My talk today is called Devnetes. It's just a little tongue-in-cheek because I'm a little tired of everybody putting K on every product and trying to make it named after Kubernetes and things like that. And part of my approach in talking today will be from an application developer's frustration perspective of what the hell is this thing Kubernetes and why do I need to use it and how the heck am I going to use it? So today, I'm going to preface a little bit. I am not architecture and graph heavy in this presentation. There's going to be a lot more talking, and hopefully I can get into some demo and some live stuff just to give you some context. But please, if you have any questions, just raise your hand and I can try to answer them as we go as well. Let's see. And I should be good to go on chat. All right. I can put that somewhere. So show of hands in the room, can't really do it online. So who is actively using Kubernetes today? Sweet. Who has heard of Kubernetes and is freaking the hell out? Okay, awesome. Who's using Docker Compose and running things locally with that as their primary mode? All right, what about folks that are still shelling into a machine, making sure you got that certificate from AWS or finding it or asking people who it is, downloading files and running things manually on servers? Anybody still in that mode? I still prefer that sometimes, and that's kind of my approach sometimes to deploying Kubernetes. But in reality, Kubernetes gives us some nice tools that can help us not have to do those things anymore, but there is a mountain to climb to get there. So I'm just going to go over some tools that we're familiar with, and then some future tools that you should be aware of, and then some techniques and things that we can use to help get us more familiar with Kubernetes in general, so that we as developers can actually deploy our applications and make them resilient and have high availability and all these nice things that we don't get with just installing Docker Compose on a random server somewhere, copying the static IP address, hope it doesn't change, adding that to DNS and going from there. All right, so today, all of our employers probably expect that we are this ultra full stack. Full stack now is going well beyond front end and back end development, is very much IT ops, which is a term I'll talk about in a sec. And we're starting to classify IT ops as a whole separate area of expertise that even standard IT doesn't have capability for, that they're trying to move into yet. But now also we are being grouped as full stack developers in this other bucket called app dev or application development or app ops or any one of those other terms we can think of on the fly. So the reality is most of us are front-end and back-end devs, and we're deployment hackers. We're trying to figure out what tools we can use to just get this stuff live so people can use it. Some of us have some good expertise in CI/CD, and the reality is a lot of people are still starting that journey and don't have deployment pipelines and scanning and testing, and whose employers actually let them spend enough time on testing. Put mine as close to the floor as possible. Also, some of us are in this environment now as Kubernetes is evolving. We say that Kubernetes and the tooling is becoming commoditized. It's creating a sense of urgency amongst the CTOs and the IT executives that they say, what is this K thing? I've heard about it for the last 3 years. Do we have it yet? Why don't we have it yet? Use it, right? There's a ton of pressure from the top down to use this thing that they don't even know what the heck it is. Also, we're finding that there are more and more rules that we need to follow, that we're figuring out how to actually have control over. And that's one of the reasons Kubernetes was born in the first place. And if we've started down that Kubernetes journey, like a lot of you probably have, and myself, and it happens about 50% of the time, you're going to have that reaction, what the hell, nothing works. I'm following these guides and everything's incompatible. So that's our frustration again as a dev. So my assumptions today, we all have a basic understanding of containers. I'm not going to go through what it is to build a container and what container images are and how to do Docker run and mount a volume and things like that. I'm going to assume we've already done some of that. We've all used Docker Compose. That seems to be the primary skill set today on how to run multiple containers simultaneously, as well as provide some resource and connectivity to those and stitch those together, give us our basic service mesh. And I'm also going to assume we have a basic understanding of networking. Networking is absolutely an evolving methodology and technique, and now we can do things declaratively, and it's shifting and changing, but we know what IP addresses are, we know what DNS names are. We're at least going in and hacking up a host file and things like that. All right, and my outcomes for today, or my learning objectives, Kubernetes isn't so scary. It's actually really helpful. We just have a mountain to climb. And I hope we at least get a familiarity with some tools or some things that we can use moving forward to help us lubricate that journey and figure out where we need to go when we're learning Kubernetes. Let's see, all right. Already got through that. All right, tools and techniques that we're used to. Does anybody not run Docker Desktop? All right, everybody's pretty much on Docker Desktop. That's good. You're probably used to using pip, node, whatever package manager comes with the framework you're used to, any of those methodologies to run local services and do your development front end, back end, and even manually create shell files or bash scripts and run those to stand up services and stitch them together. We're also used to, as developers, going in and saying, hey, Bob, what's the IP address of your computer? Let me add that host file so that you can test somebody else's workloads and do things like that manually. And we're also used to SSH and file copy and some of those other things that are just painful for managing our deployments. The new reality is that the complexity of this stuff is increasing dramatically. We've got a whole new professional field for this. We're not grouping it, or I personally am not grouping it into the same thing as just general IT. General IT now is truly shifting towards just hardware management to how do we provision my printer in my office and things like that. But then also on the other side, now we're seeing a lot of tooling there that's pushing things into automation, and it's creating this whole new massive mountain of tools for IT to better help create a foundation or an environment that you can deploy your applications into. That covers everything from DevOps to control plane management, infrastructure management, bare metal server allocation, or now bare metal is often compared to AWS and an EC2 node. We're also heavily focused now on compliance and role-based authentication and access controls, as well as our end user support and our uptime. We're seeing SLAs becoming more commonplace. Finally, it's a good thing, but we as applications developers need to understand what those business requirements are so that we can design our applications for resiliency. And then we're seeing all kinds of new ops terms. I threw data ops in here because it's really important, and part of what we run as our best of breed ground up stack in Kubernetes is going to be our traceability and our monitoring, and that'll be Grafana and Prometheus and a lot of these other tools that are actually giving us insights into the applications and the infrastructure that we're running. You're going to see that as ML ops, or does anybody else have some ops terms that they've heard of that aren't? Check the chat. What was that one? Yeah, Git Ops, and Git Ops is awesome. What was that? Chat Ops? I haven't heard that one. Got it. Yeah, absolutely. And a lot of that is going to be that network connectivity and service mesh and whatnot. Let's see. All right. And then we're also now being given sandboxes in our resources. So how do we actually have resource management? When I need to deploy an application, I need to, as a developer now, understand what it means to right size nodes and actually specify how much resource my process requires. You know, how much RAM does this thing require? We have to create and provide limitations for that. Let's see. So we're going to jump into some essential tools. So today we use Docker, right? But Docker is shifting and moving away. Docker is now reasonably a closed source commercial application. And there's a lot of other applications that have been developed now to give us Docker-like functionality or mirror the Docker CLI. And allow us to do the same kinds of things, but in a trusted open source fashion. And that's why we're here today, is because we're interested in open source. So I'd recommend people check out Podman. Podman's a great tool. And it also gives us Podman Compose, which you can alias to Docker or Docker Compose. So it's an easy way for you to shift away from the Docker CLI instantly today. Another great tool, which is a little bit more visible, and we'll talk, I have a separate section of a resource page that we'll deploy after the talk. But Rancher Desktop is another great one. And I'm going to talk about Rancher here in a minute as a learning tool and as an initial tool. That's a great way to start your journey. A lot of our talk is going to center around leveraging some of that, especially the demo portion. But Rancher Desktop actually helps stand up a Kubernetes environment just like Docker Desktop does, but it uses the nice open source offerings underneath the hood and still gives us the resource control management as well. We're used to package management, right? Doing npm install and things like that. And we're used to using Docker Compose to deploy multiple applications in our complete microservices application stack or whatever our local development stack looks like. So Docker Compose up is ingrained in our keyboards now. Helm is the package manager for Kubernetes with big air quotes, right? It's doing more than package management. In reality, it's a tool that we can use to develop and deploy complete application stacks and provide configuration files and extensibility and allow somebody to deploy our applications within their infrastructure without having access to all the source code, right? It's just directing and providing resource definitions to stitch things together. Let's see. So it's like Docker Compose on steroids. Some additional utilities to take a peek at. RKE, which is a great tool for deploying the Kubernetes clusters themselves in general. If you follow the docs for RKE, it'll walk you through how to allocate nodes on AWS or other bare metal or virtualized infrastructure, download the certificate and place it into a YAML file and run it through a CLI. It's really, really, really easy to stand up the clusters that way. Otherwise, there's a lot of complexity with having to shell into a server, stand up a Kubernetes agent, have it talk to another server, and do a lot of the extra things. So that's going to do a lot of the heavy lifting for you to deploy these clusters. Also, K3S, which is a lightweight container runtime. It helps run Kubernetes anywhere. You can deploy that on just about any size of infrastructure and run Kubernetes, and it interoperates with RKE. And then another one that's useful for us on our journeys is Compose. Compose is great, and a lot of people use it to actually convert Docker Compose files into Kubernetes resource files. Let's see. A platform. So I'm absolutely a hacker when it comes to figuring these types of things out. I need to leverage a platform and something that I can see and feel and touch and break and hope fix and look up docs, right, in order to understand what the underlying fundamentals of a system are. Rancher came out several years ago. It's really, in my mind, the first and best true open source solution for managing Kubernetes. It runs on Kubernetes and it runs Kubernetes, which sounds kind of Inception, but it's an amazing tool. OpenShift is also another great one. And there's a ton of other major platform tools that are coming out from all the providers. But Rancher really, I feel, it is the best path forward if you want to pick up and use a platform and leverage that platform to learn Kubernetes while you're using Kubernetes. So we're going to talk about that in a sec. All right. So what I'm going to do is I stood up a new cluster today, and I'm just going to give a quick tour of Rancher itself. But I want to poke through Rancher and show you and leverage that as a way to take you on a tour through Kubernetes itself, mainly to help you see that Kubernetes really is a massive collection of resource definitions. It's a bunch of configuration files that are telling a number of services how to talk to each other and what's there. And Rancher is going to give us some nice automagic way to deploy some workloads, but then it's also going to give us full visibility into that cluster and into those resource definitions, and give us access to kubectl and those other tools without having to download a bunch of stuff on our local machines. Let's see. Before I roll into that, are there any questions so far? I'm sorry for the online folks. My phone keeps shutting off. And can you hear me okay? Sweet. All right. All right, so this, by Zoom, oh, come on, give me a better. I'm sorry, I don't use a Mac, but I'm using a Mac. Command plus. There we go. Thank you. All right. So this is Rancher. And I don't want to turn this into a product demo. I really want to leverage this as a way to show you Kubernetes. So just keep that in mind. If it turns into a demo, just yell at me. It's okay. So this is a live environment. We're managing several clusters here. These are all live production clusters. Well, some of them are dev clusters as well. From the outset, it's really, really, really easy to create a new cluster. So Kubernetes has a concept called cloud providers. If you use a cloud provider, it's a predefined integration with someone like AWS, Azure, Linode, Oracle, Alibaba. There's a ton of others, or on-premise infrastructure as well, like vSphere. SUSE also has an offering. Harvester's coming out, which is hyperconverged infrastructure which interoperates with this with Rancher already. So you can actually leverage this as a tool to virtualize your on-premise infrastructure with those cloud providers, and treat your hybrid or treat your cloud infrastructure the same way that you treat those. So you can virtualize and say, I want a 2-core 4 gig CPU VM to deploy my workloads on, and things like that. So it's really, really easy to add and create clusters. What we can do is we can also create node templates. So node templates are predefined machine images that we can use. So we specify node templates, and those node templates are also include resource size and allocation. And I'll show you when I create a cluster why we use those node templates and what that looks like. But a lot of times those will also contain specific pass roles or other IAM roles that tell that machine what its permissions are within that network. So we predefine those so that they can be reused by different people. One of the things that's really powerful about Rancher in general is Rancher does give us role-based authentication out of the box. That's something that's becoming more and more mature and required for our infrastructure stacks. We can't just freewheel it anymore. Especially keep in mind, Kubernetes is inherently insecure. It is not a secure application stack. Expect that it is not to be trusted. It's really up to you how secure you make this. So I created a cluster today called Devnetes. And right out of the gate, we're getting visibility into CPU utilization, memory, number of pods, everything there. So does anybody here know what a pod is? So a pod is essentially a cluster of containers that are operating together as a unit, as a single unit. That's a core fundamental building block of Kubernetes. You need to understand what a pod is and how that works. From an application developer's perspective, I would recommend taking a peek at Istio, that's ISTIO, and learning how Istio leverages sidecars to create and manage network connectivity for you. That'll give you a nice insight into why the hell do we use sidecars? Why do we have multiple containers running as a single unit and not just one big massive container that contains all of my requirements and dependencies? But it's a good way to go down that road. Let's see. Kubernetes is meant to run as in a highly available format. That means you need to have master nodes, a collection of master nodes, and a collection of worker nodes. Different flavors of Kubernetes use different storage methodologies to share information between the different master nodes. Here, this version uses etcd to share information between those. But you want to run, you can run Kubernetes on a single node. A lot of our development machines will have that with Minikube or some of the other flavors. But when we run a production cluster, we want at least 3 different master nodes, and we want to operate those separately than our worker nodes. You get into a situation where you can create deadlocks because your containers or your workloads actually freeze the master nodes that they are running on, and that can cause major problems there. Let's see. One beautiful thing with Kubernetes, right, is it's managing the network stitching for us. So what we can do, and Rancher gives us nice tooling, is we're leveraging a cloud provider and instantly scaling our deployment just by clicking plus or minus, or deleting a node on the fly. And it will automatically, in a zero trust fashion, issue certificates to those nodes, establish secure communication, and create a network for us on the fly. Another beautiful thing here with Kubernetes, with its resiliency, if we define uptime requirements and we define health endpoints, if we kill a node or a node gets frozen, so I'm just going to delete one on the fly, it will actually re-provision a new node and stand that up and go through the same process. Same thing happens with workloads. If one of my workloads fails, it'll stand up a new workload and move it to an available node, and we've got instant uptime, right? We've got that dishing around. Now, us as applications developers, that's a godsend, but it does change the way we need to think about how we design some of our applications. If we're doing like a static site build, right? You can't necessarily build those files at runtime. You need to build those files at build time and create those static files so that you do have the same hashing and other things with your front end and the front end files as those get shared amongst multiple workloads. So we'll condense some of this. So Kubernetes has a concept called namespacing. Namespacing is used to create, and I'm going to oversimplify, so somebody's going to yell at me about this, but they create distinct environments inside of a cluster for us and help isolate those environments from each other so that we have some permissioning, is that a word? And some escalation principles so that we can have a dev environment which doesn't cross-pollinate with a staging environment, which doesn't cross-pollinate with our automated CI/CD and build chains. One thing that we'll leverage internally is we'll actually, each time a Git commit is made or a branch is created, we'll automatically, with these resource definitions and with environmental variables, we'll provision an entire new stack under a new namespace and automatically allocate DNS and do everything there just because somebody did a pull request. That way we can instantly go and live test and see what's going on. Does this actually work? Can I allow a user to experiment with a feature, things of that nature? Let's see. All right. So I'm gonna hack this up, and I didn't throw it into a standard namespace. I just threw it into the default namespace. Now, when I want to run this locally, when I want to run Kubernetes locally, you're going to see references to Helm. Helm is the best way to install an application on Kubernetes. In order to connect with Kubernetes, you need several things locally. You need Docker or a Docker compatible runtime. You need kubectl, which you can download and install, and we'll provide those resources later. And it comes with a lot of those, it packaged up with Docker or Rancher Desktop. And you also need to install Helm if you want to run Helm. But what that is Helm is going to interact with kubectl and actually connect to your cluster for you and run some commands on Kubernetes on your behalf. Let's take a look at what that looks like. All right. I'm not going to scroll down because then you get the full secrets, and this is recorded. I'm going to have to kill this cluster later anyway, I guess. Terrible secrets management. That's what we get out of this talk. So kubectl uses a config file. That config file gives us secret values, passwords, basically, as well as locations of the server. That can either be DNS names or just straight IP addresses. Your local machine is going to use that information as a way to attach itself to the cluster and run those commands on your behalf. If we use a tool like Rancher, let's see if I can, oh, don't make me scroll. Come on. All right. If we use a tool like Rancher, it gives us a nice integrated shell, which gives us Kubernetes from the outset, gives us kubectl from the outset. All right. All right. So if we use the command kubectl get all, it's going to display all the resources that we have. Now, Rancher does some nice namespacey things, so I don't know if this is actually all of them. There we go. All right. So one of the things that Rancher will do is Rancher deploys a lot of other utility workloads alongside our own workloads. Those are things like cattle monitoring system, which is going to be Prometheus and Grafana and some of those other things that are necessary. It also will run, modern Rancher will also run FluentD and some and other tools that allow us to create custom alerts and redirect alerts and send those to Slack and help get some insight into the health of our infrastructure. See, I also have a utility here that I was going to show if we have time called KubeCost, which gives us visibility into our resources and actual understanding of how much is this cluster costing me, which is hyper important for us moving forward as applications developers, because you'll hear a trend and a lot of the Kubernetes talks that I've heard this conference, Kubernetes can be expensive if it goes unchecked. So it's good for us to have insight into that. So all of these are different resources. They're all YAML files, essentially, that are defining how things are talking to each other. So if you ever need to poke around, then you can use kubectl get all. But we can use the Kubernetes dashboard or Rancher's version of it. So what I will do as a developer is I'll leverage, and I'll show you how to deploy a workload here in a second. I will leverage Rancher and deploy a workload and do things through the UI, and then actually go work backwards and go check out the definitions and see what was created so that I can understand that and then apply those moving forward. It also allows me to make small minor changes within the files because I prefer to do that rather than go find the ranchery way to do things through a user interface. And that's the way that I do the same thing when I use other user interfaces. Let's see. You'll notice here, we have several different types of ways to run pods. One of those, so running a pod is called a workload, right? That's what we would consider our container. A workload can be deployed as a cron job. We like cron jobs, as a daemon set, so across all the nodes, or as a standard deployment, which means just a long running process. That's what we're used to seeing when we run our containers in Docker Compose. It can be run as a job, so maybe a one-time job, or stateful sets. So they need to stay alive. Those get grouped up into pods. And so you can see here, I have full visibility into these pods, and I have 90 pods running. I created this cluster today and deployed maybe 2 applications on it, and I already have 90 pods. So that just shows we need something to help us manage the complexity here in Kubernetes. Also, we have service discovery. So in service discovery, we can create ingresses. Ingresses are ways that traffic from the internet are going to get to our container workloads internally. I've created 2 websites, and I hope my deployment of one of them works today. But we've got devnetes.com and netes.dev. So my goal here is to use netes.dev as a staging site and devnetes.com as a production site for just an MK docs site that has some resources for the tooling that we're talking about today. And we'll be talking about this more and more and more. So I'm going to be updating the resources there, and feel free as you're going through your journey of learning this stuff to contribute back to that or add issues and ask questions. And that'll be up on GitHub as well. Services are internal ways that we actually stitch our applications together from a networking standpoint, right? It creates those internal network addresses that allow our machines to communicate with each other. We're used to seeing a Docker Compose file. Let's go to the Docker Compose file. All right, so this is a simple Docker Compose file that we're all used to seeing. So I've got volume specified, which is an important concept. I have ports that I'm opening so that I can access those locally. And I'm specifying how the network operates. All of these things are convertible into configurations in Kubernetes as well. Now, my service here, docs, is actually Docker creates that service reference on the fly for me using Docker Compose. And when we move to Kubernetes, we need to create that reference manually or create a Helm chart that can help us leverage our Docker Compose and actually deploy that stuff for us. All right. Let's go back to. So as developers, one of the powerful things that Kubernetes gives us is it does give us more flexibility and allows us to do more with compute resources. We can't do everything on our machines anymore unless our bosses are super nice and give us a 64 gig, $10,000 MacBook Pro or something like that. As we move forward into the future, our terminals act more as a thin client, right? And if we can keep the cost down, then we can do more and more and more in the cloud and leverage infinite resources when we need those. So I'm going to take a look here and go to my workloads. One of the things that I really, really liked about Rancher that is changing was the concept of pipelines. So pipelines was an integrated Jenkins X-based CI/CD tool that leveraged a Jenkins file that allowed us to actually build our images and then deploy those images into a local cluster. Why this is important is we can operate our full CI/CD stacks now isolated into namespaces alongside our applications instead of having them in their own one big monolithic CI/CD environment. And we can deploy that stack alongside the application. So we truly have one single holistic offering. If anybody's actually building applications here that are not SaaS, that need to be deployed inside of a customer's infrastructure, that can be incredibly important. We mentioned Git Ops, right? Git Ops is a way to create declarative, single source of truth where our applications build themselves from the ground up. And we can leverage Git Ops as well to specify the CI/CD environments as well to build that stuff from the ground up. So here I've created a pipeline that leverages the Docker file and a Rancher pipeline file just to simply build an image and push it to a local registry. From that, we can pull a local workload and actually deploy this on the fly. I don't have time today. I was going to show how to install Let's Encrypt and or Cert Manager via Helm chart and actually do certificate allocation on the fly, but we'll have to work with what we got today. So we only have a few more minutes. So if you go to needies.dev today, you can actually get to the site. Does anybody know how to get past? It's just a life pro tip. I know how to. I'm just curious if somebody doesn't know how to get past this screen. Just type "this is unsafe" on the keyboard, and that's all you have to do to get past that screen. It's really hacky, but it's a lifesaver. Boom. So all I did earlier was just deploy a hello world here so that we can demonstrate that. Now, if we go to devnetes.com, we've got nothing, right? It's not resolved. So I've leveraged external DNS. External DNS is a workload that talks with Route 53 or other cloud providers and actually creates those DNS names for us. So as a developer, I'm going to go into my ingresses or load balancing, and I'm actually going to create a new ingress and direct it to that container. So I want to say this is devnetes.com. I want to put that in my namespace alongside my workload, so development. I want to choose a workload. So there's a concept of selectors in Kubernetes. You can direct traffic using labels on these containers. You could say direct traffic randomly to any container that has a label of app equals my app. and it will round robin by default, or round robin load balance across all those workloads. Here, it's actually specifying by name, select this workload that has this name. Let's see, actually want to create a service. Created a default path, and I want to specify a host name to use. So I'm going to say devnetes.com. We can provide a default certificate. I'm going to leave it alone for now. And I'm just going to hit save. If I go back to external DNS while that's creating, I'll view the logs here. And we can actually see that we've picked up wildcards that were specified in configuration for devnetes.com and netes.dev. So it's going to try to create those if it detects a change in my ingresses. So what external DNS is doing is it's actually watching the ingress resource definitions in Kubernetes, the ones that it actually has access to, and is trying to do something based on what those configuration files say. When I create a certificate, it's the same way. Let me go over to so this is actually our live company website. If I go to ingresses here or load balancing, I can check out and see, let me see what this looks like today. So Krum.io is pointing to an internal service. We've got our host name and we have certificates specified. So I need to do a little bit more change. I need to make a little bit more of a change than what is available on the UI. And this is where I, as a developer, start to learn a little bit how to do things the Kubernetes way. I know we're running out of time. And thank you all for staying until the very, very end of the day. This is total conference trash time, but I love it. All right. So we have an ingress here. And what I'm going to do is I'm just going to edit the YAML directly. So this is what a YAML file looks like. So we have several different annotations. We've got certain managed fields, so things that Rancher is actually changing for us in these configuration files. And nobody wants to configure this stuff from scratch. And this is a great, great reinforcement of why it's good to use a tool like Rancher. Let's see. Down here, we're actually specifying rules here. So one of my rules is for this host, if I have traffic that's coming in and looking for this host, redirect it to my workload or my service name, Krum Web, on port 3001. Also, I'm specifying TLS for my certificate. I need my certificate name, my certificate source to match www.krum.io. If it's a mismatched certificate because I configured things wrong, then it'll give me that nice warning, right? It won't work properly. And it's also storing that in a secret. Now, when we talk about workloads and annotations, annotations can be read by other workloads in the cluster. And so I've specified, hey, cert manager is what talks to Let's Encrypt. Use the cluster issuer, Let's Encrypt production. Let's Encrypt staging is temporary certificates. Production is throttled, so you can't make too many incorrect requests or it dies or kicks you out for a week. So we're saying Let's Encrypt production. Let's Encrypt picks that up, checks the host name, and generates a certificate and stores it in the secret for us, and does that all automatically. Let's see. I did want to show. So one thing that's really important, and we'll wrap up with that, is how do we actually interact? We need to know how to interact with these workloads locally. This stuff is running up in the cloud on the fly, isolated by itself. That's going to be difficult to debug and actually work with. It's also going to be difficult to connect to. A lot of us get in a situation, especially when you deploy a database, that it's behind a firewall somewhere and you have to jump through a bunch of hoops to access it. You have to have a bastion host, right? You have to do all kinds of things. And especially if you're trying to do that from your development environment and work in a development database that's behind those firewalls, that can be a huge pain. So if we want to actually, and it takes me into KubeCost, if we want to redirect, we can actually connect to our cluster and redirect traffic from a certain workload back to our local machines. We can do that in a proxy format and a reverse proxy format. You want to do it in a reverse proxy format, so we can intercept a workload that's going to, or traffic that's going to a live workload. So I can intercept all traffic that's going to my website and redirect it to my local machine and have that traffic go to my local workload. A good tool for that is called Telepresence. Telepresence is a CLI that lets us do that, and you can specify a certain local port. So if I've already stood up a workload, I use Telepresence to say, point this service that's online at my local port 8080, and it will run that proxy for us. But if we want to connect to something ourselves, like a database, then we can use kube proxy or kubectl port forward. Here, I've already got kubecost installed, and in order to show kubecost, I have to run that kube proxy. So here, I do that too. I'm running kubectl port forward, namespace kubecost, deployment, kubecost cost analyzer, and I'm directing that to port 9090. So now kubectl is telling that traffic, or telling my local traffic to go up to that workload in the cloud. And if I hit localhost, then I have instant access to my live in Kubernetes workload. I can use kubectl to switch between clusters as well, and rinse and repeat and do the same things. And then kubecost is a great way to get visibility into the cost, so you actually understand how much this is costing. I stood up this cluster today in a high availability format, and it looks like $243 of my monthly time is going to be spent on idle compute because I'm not right sizing my nodes properly. Let's see. So I think we're out of time. I would highly recommend, if I was going through this journey again, definitely try to go deploy your first Kubernetes cluster, whether you use EKS or anything else, install Rancher on it, and leverage that as a way to move workloads into Rancher or into Kubernetes, and then try to dissect what those look like behind the scenes. And that'll teach you a lot about networking, load balancing, and all those other things that Kubernetes gives us, but we have no idea how the heck they work. Cool. So I'm going to deploy this, some of these resources later on, not in a live demo environment, so that we have a list of tooling and some other things, and hopefully mature that site as well. But I hope as application developers, this can at least help you get started and make it a little bit less scary and get moving in the right direction, so that you can tell your bosses to fire all the IT ops people and give you more money. Cool. So thank you very much.